Welcome to the project demonstration of automatic street light controlling system and fault identification using LDR sensors and day and night mode using the one more LDR sensor, and also vehicle and person detection using this sharp IR sensor which can detect the obstacles up to 3 feet of distance. And one more thing is the rain detection. So when the rain falls, automatically it will detect the rain, and the so-called status continuously monitoring on the Blynk application, so in your phone. And here we are using Arduino Uno board to communicate between the input and output modules. So the input modules are like two LDR sensors. One LDR sensor mounted here to check the day and night mode, and one more LDR sensor we placed inside this street light to detect the fault. The purpose of this LDR is when we are switch on the when the Arduino Uno take a decision to switch on the street lights, then it will check with the LDR sensor whether it is faulty, means it's on or off. So if it is off state, then it will inform to the Blynk application by sending the information of alerts. So like there is a light fault and also the rain data. So above the gauge displaying the status of the rain percentage, that is 0 to 100%. When it is above 45%, then it will inform the alert message in your Blynk application if you don't open the application also. And the next is for the communication between the Blynk application and the kit. So we are making use of this ESP8266 module, and the whole system driven by this battery. So the battery ratings are 12 volts, 7 ampere per hour, and which is a rechargeable battery. So there are two sources we are providing to recharge this. One is a solar panel. Here we are using this solar panel ratings are 12 volts, 20 watts. So it will take minimum at least of 6 to 7 hours, minimum maximum of 10 hours to be fully charged for this battery ratings. So if it is cloudy, it may take up to 12 hours. If it is full sunny day, then it will take at least 7 hours to be fully charged from this solar panel. So if you want to charge a battery when there is no sunlight, so we can charge a battery from this transformer by providing the 230 volts input to the transformer. So directly there is a bridge rectifier circuit and regular power supply board. So these are used to convert the AC to DC and then DC to the pulsating DC to the pure DC voltage, and that was given to the directly to our 12 volt 7 ampere battery. So if you want to charge a battery from this transformer, it will take maximum of 12 hours to be fully charged. So till that you should keep on the charger. So let us see the demonstration. Before switch on the kit, so as usually we need to enable the hotspot in your phone. So just go to hotspot settings in your phone and change the hotspot name to project 5071. So on the hotspot, change the hotspot name to project 5071 and the password should be 129. So after enabling the hotspot, check the twice clearly without any space, without any capital letter on the hotspots on the data, and then log into the Blynk application. So initially it will show the status of the device is offline state. So here is a main on off switch. So let us actually it should be closed here. So let us see. So on the kit, there we get the device will be online now. Data no? No. So right. So now the device is online, and now so there is no rain detection and there is no input from the rain sensor to the Uno board. So let us pour some water on the rain sensor. Here is the rain sensor. Right. So there we get the alert, rain detected. So you can wipe out that. So it will inform the alerts directly. So you don't need to see the app continuously monitoring purpose. Just if you close the app also, you will get the message alerts as a notification in your mobile phone through the Blynk app. So it will be refreshed for every 2 to 3 seconds. And meanwhile, let us go with the street light operation. So just you need to cover the LDR sensor. Yes, I'm holding the LDR sensor. You can see that it's going to be the 50% of brightness. Whenever any vehicle or a person detects, then automatically the brightness is increasing. You can see that. In day mode, automatically off. Okay. And again, night mode, 50% brightness. And when a person enters or detects, or the vehicle detects, then automatically the brightness increases for 100% and then stay there for 5 seconds. So in real time, we can increase that. So let us see the fault also. So just for that, I am disconnecting the street light from the system to disable that. So I have disabled that. I'm supposed to get the on here. So you can get the notification here. You can see that on in the app. So there is a red light indication over here and fault LED street lights. Right? Okay. And again, connecting back. Right. So here the LED ratings we are using is around of 150 watts of power consumed by this street LEDs, and LDR ratings we are using 15 mm LDR to check the light status as well as the day and night mode purpose here. Right. Okay. So there is a closer explanation of the components. So here we are using these two are the charging circuit. We can see these two are look like same. So these are called regulated power supply boards. So here when we are providing the transformer outputs to this regulated power supply board, so there are the 4 diodes will act as a bridge rectifier so that we will get the pulsating DC. In AC input, pulsating DC output, and the next stage is smoothing purpose. We are using 1000 microfarad capacitor, so they will get the pure DC voltage, and after that there are the 2 diodes. These 2 diodes acting as opposite current flow stopper, nothing but as you know the diodes will work in forward bias. So whenever the current is flowing from the transformer section to the battery, then these 2 diodes are in forward bias. Whenever the battery is fully charged, so that these 2 diodes stops the current flow from the battery to the transformer to protect our charging circuitry. So coming to the solar charging circuits, there also we can see the 4 diodes. So here we are providing DC power supply from the solar panel. So the purpose of these 4 diodes is these 4 diodes act as a polarity corrector. Means whenever we are providing DC input, we should check the polarity plus and minus. So if you place mistakenly place to minus to plus, then there may be chance of the battery damage or circuit damage. So in order to protect that, we are using these 4 diodes as a polarity correctors so that they will make the plus to plus, minus to minus. So the capacitor purpose is just in order to remove the ripples while we are doing this polarity correction operation, and the remaining 2 diodes purpose is same. So here if you switch off the kit also, due to this low lighting from these tube lights, so now the system is providing some power source from some voltage to charge a battery. So when we place this under the full sunlight, so we get maximum of 15 volts. So because if you want to charge a battery of 12 volts, then you should provide the 14.5 volts minimum. So that is a high potential power supply, then only the low potential battery can charge. Okay. Yep. So remaining components are Arduino Uno, ESP8266 Wi-Fi module, and this is the LDR board for the street light fault detection, and this is the MOSFET to control the intensity of our lights. So here we are using IRF 540 MOSFET, and this is the buck converter. So the main purpose of this buck converter is by taking 12 volts input, Arduino will damage. So that's why we are protecting that by providing the 12 volts to 5 volts regulation. So that will be done by this LM2596 regulator, which will provide the 3 amps of current can be handled by this one. So remaining, this is the one more LDR to detect the day and night mode, and here is the breadboard just to distribute the power supply throughout the circuitry. And the next, this is going to the rain sensor amplifier. So this is the rain sensor module. Alright.